Let's go to question number 3. If triangle EFG is similar to triangle RST, what is the length of RS? Well, here we go again. We probably want to write a proportionality statement so we can figure out what sides match up here. So I'm going to go ahead and do that here on the bottom. Looking at our similarity statement, we know that EF corresponds to RS, FG corresponds to ST, and GE corresponds to TR. Okay, so what is the length of RS? Looks like we have to use our first ratio, definitely, so I'm going to write that down. We got to use EF over RS, and let's find a ratio where we know the top and bottom. FG, we don't know, so that one's out. GE, we know GE. TR, we know GE and TR. There's our next ratio, GE over TR. Okay, let's plug in our values here. So EF is 7.2. RS is what we're looking for. GE is 7. And TR is 24.5. Now we've got our ratio, or our proportion. Let's go ahead and solve it. I'm going to write it up here so you guys can see where we're going with this. Okay, so we've got 7.2 times 24.5. I'll put that in my calculator. That is 183.6. And that's going to equal x times 7, so 7x. Divide both sides by 7, and you end up with x is approximately 26.2. So our answer here is RS is 26.2 centimeters. And I'll label that. RS is 26.2 centimeters. Alright, so there's our first unknown side. What is the length of GF? Let's take a look at our statement of proportionality. GF is the second one. FG, oops, that's not FG. I wrote that, I have no idea. Take a look. Okay, let's take a look at our statement of proportionality. We're looking for GF. That's ratio number 2. So we've got FG over ST is equal to, that's like GE and TR. We know those two already. Let's just use that again. GE over TR. Sometimes the previous problems help you solve the new problems. Okay, let's plug in what we know and don't know. FG is our unknown. ST is 18. And we already know GE over TR. It's 7 over 24.5. Let's cross multiply. X times 24.5 is 24.5x. 18 times 7 is 126. Divide both sides by 24.5, and you end up with x is, whoops, it's not an exact number. X is approximately 5.1. So our answer here is GF is 5.1 centimeters. Let's label that 5.1 centimeters. Our numbers look like they make sense. This number looks like it matches up with about the same length as RT. GF all looks pretty good, so logically it looks like our numbers make sense on this problem. Question number 4. For the 30, 60, 90 triangle, find the length of CB and AC and label the diagram. Now, we've talked about this before, class. You can actually use trigonometry to solve for these sides, but why would we do that? We know there's rules for the special triangle 30, 60, 90, and those rules are the short leg, CB, the shortest of the two legs, is going to be the value of x. That if it's x, that means that the hypotenuse is 2 times x, and the long leg is x times the square root of 3. So all we got to do is find x. If we can find x, we can solve any side in this triangle. And the way we do that is simple. Just put an equal sign on any of the sides you know. So you know, class, that 2x is equal to 18. Let's write out 2x equals 18. Oops. 2x equals 18. And that means x must equal 9. And that means that we know that CB must be 9. Because CB is the same as x. So we already found CB. CB is 9 centimeters. And then how do we find AC? Well, we know that AC is equal to x times the square root of 3. Once you found x, class, all you do is plug it in. So in this case, if AC is x times the square root of 3, and we know that x is 9, then AC must be 9 times the square root of 3. Sometimes I will leave it this way on a test or a worksheet, because that's the exact answer. Sometimes I'll ask you to go ahead and estimate that as a decimal. Let's do both of those. Let's put this in our calculator. 9 times the square root of 3 is about 15.6. And that means the length of AC is approximately 15.6 centimeters. Now the question said label the diagram. We've done that. We've labeled all of our side lengths. Let's take a look at number 5. It's a 45, 45, 90 triangle. We know the rules of 45, 45, 90. If we label a leg as x, then the other leg has to also be x, because this is an isosceles triangle, and the hypotenuse is x times the square root of 2. So how do we solve for our sides? Well, class, all we got to do is put this equals here. We know that the hypotenuse is 35. That means we know that x times the square root of 2 is equal to 35. Let's write that out. Looking for PR. We know that x times the square root of 2 must equal 35. Let's divide both sides by the square root of 2. I'm going to write that because some of you are dividing by 2. You can't do that. 2 is not in this equation. Square root of 2 is. And this ends up being x is equal to 35 over the square root of 2. That'd be our exact answer. We can put that in our calculator and approximate that to be, looks like it is 24.7. That means x is 24.7. Well, PR is x. So that means that this side is 24.7 feet. And then RQ is also x. So that means it also must be 24.7. And this is also 24.7 feet. We have found our side lengths and labeled our triangle. Number 5 is done. Please, class, every time set it up the same way. There's no confusion here. Put an equal sign on any side length that you know to make it equal to the rules of the particular triangle you're working with. Solve for x. Everything else from that point on is easy. What is the length of side or segment CF? This is a triangle proportionality question. We've learned this through our notes of similarity. We know that if you have two parallel lines, a parallel line that's inside of a triangle, if it's parallel to one of the sides, then we know that EC over CF is proportional to ED over DG. So let's go ahead and plug in what we know. EC is 40, CF is our unknown, ED is 32, dg is 24. Let's go ahead and do some cross multiplication. 40 times 24 is 960. 32 times x is 32x. Divide both sides by 32, and you end up with x equals, looks like it exactly equals 30. So we can go ahead and label our triangle for CF, that is 30 inches, and our answer here is going to be CF is 30. We can just use the inches designation, that's fine. CF is 30 inches. Okay, one more, I think we can fit it in. It's another triangle proportionality question, but they don't give us a labeled diagram. We got to label it ourselves. RV is 22 meters, so that class is the whole thing, 22 meters from R to V. WV is 6 meters. RS is 15 meters. And ST is what we don't know. Now our problem here is we need to know what RW is to use triangle proportionality. We have to do it by an equation. So we know that RW plus plus WV is equal to RV. Those two line segments together add up to the whole thing. So I know that RW is going to be equal to RV minus WV. RV is 22, WV is 6, so that means RW is equal to 16. So we had to figure this out first, 16 meters. Alright, now we can set up our proportion and solve. We know that SW is parallel to TV, so these two sides are proportional to these two sides. So let's write our statement of proportionality. RS over ST has to be proportional to RW over WV. Alright, let's plug in our numbers. RS is 15. ST is our unknown. RW is 16. WV is 6. Let's go ahead and cross multiply. 15 times 6 is 90. And x times 16 is 16x. Divide both sides by 16. And we're going to get an approximate answer here. It's approximately 5.6. So I will, doesn't say to label the diagram, so we're okay, but I would like to write this as a sentence answer. So my answer is ST is 5.6. Our unit of measure is meters. So there's our answer to question number 7.